Hello and welcome to our live coverage of Embedded World 2025. This is Elektor Lab Talk number 31, and I'm joined by our usual familiar faces. Stuart Cording. Stuart, how are you doing?
Yeah, I'm good. Thanks very much. It's been a really exciting show again, and we'll probably go into the details a bit later, but it's interesting to see that there's sort of a different focus at this Embedded World compared to what we saw last year, even at Electronica. So yeah, we'll talk a bit more details in a moment.
I'm sure we will. And Jens, how's it been going for you?
It's a very exciting show. I can only agree to Stuart. Many booths I didn't know. So many new companies to discover and many new products and so on.
Yeah, lots to talk about. I've got some photographs from you, some photographs from me. Stuart will paint a picture with his words, as always.
Exactly.
What's been the best thing you've seen so far?
That's interesting. I sort of half prepared for this question. So I think we saw a lot about machine learning in previous shows, and I think what we're seeing here is a bit more of a spread of topics. So there's definitely a new sort of interest in IoT. There's a technology called Halo. So when we look at Wi-Fi, for example, Wi-Fi is focused on getting more bit rate, more throughput, and making gaming better, making video better. But at the same time, we've seen lots of wireless IoT applications coming onto the market, and to get them to connect to the internet, you obviously need a gateway or something because they're not Wi-Fi compatible. Well, the Wi-Fi people who look after the standards, they sort of recognize this at last, and they've come up with the Halo standard. And so if you imagine that you've got Wi-Fi 6, Wi-Fi 7 getting more and more speed, we've got Halo at the bottom, which is more about connectivity and battery life. So I was talking to a company called Morse Micro, finding out about what they're doing. So they've got a nice little chipset with a radio. An interesting thing they were saying was the radio efficiency of a typical Wi-Fi chipset is about 6 to 7%. So if I put 1 watt in, only sort of 7% of that energy is being turned into radio. With their Halo technology and the implementation they have, it's about 33% power efficiency. And they do that instead of having a linear power amplifier in there. They've actually got a digital amplifier, and they're essentially sort of switching between power outputs rather than using a linear power amplifier to control the output. So I found that quite fascinating. Another big thing which we can talk about a bit later on is the Qualcomm acquisition of Edge Impulse, because that goes back into the machine learning side of things. And I think the other big technology change that I've got on my list is the sort of focus on Rust as a programming language. Now we've touched on Rust quite a few times in recent issues in Elektor. What we're seeing at the minute is some sort of consolidation. So the big players, I was talking to Adacore recently, they're known for safety, functional safety, qualified compilers and tools. Now they're actually taking on Rust and making it ready for things like aerospace, space applications, defense, safety critical medical. So it's sort of Rust is growing up a bit. So if big players have got safety critical software to build prepared to use it, then I think Rust is something worth looking at. We've also got Ferrous Systems. They've released the latest update of their Ferrocene compiler, which is another qualified compiler, mostly targeting automotive. And so Rust is a big thing that's going on, and it's definitely starting to make waves and push forward.
Yes, and I like that name. It's appropriate for Rust. Ferrous Systems, right?
Yeah, perfect.
And for you, Jens, what was the interesting part?
I've seen a lot of interesting things. I also was at Edge Impulse, and they have a very interesting demo using a large language model. You can use that large language model also to recognize things. They have a nice demo with model cars. And this in this demo, the model does not only recognize the car type, also the color and also the plate on the car. So it's very interesting. And with Edge Impulse, you can then modify the model a bit, because large language models, we know they are sometimes tending to hallucinate. So you cannot trust them fully.
Yep.
And with Edge Impulse, that's a very nice approach, I think. So we will definitely hear more in this year about that.
Yeah. And the other important news about Edge Impulse is that they've been acquired by Qualcomm. Yeah. That's a big thing. Like we've seen these types of acquisitions before, where someone's come along with one of the big semiconductor vendors has come along and invested in a software company, and everyone's sort of concerned, does that mean that all the microcontrollers that are currently supported, they'll lose that support? I was talking to them today, and they assured me that that's not part of the game plan. The intention is to maintain that big community around Impulse that's there. But one of the other interesting things, as you say, about the large language models, in the most recent article issue of Elektor magazine, I was writing about the way those large language models are being sort of integrated into microcontrollers. So we've got 50 billion parameter large language models, but despite their size and complexity, it's possible to reduce them. There's a lot of researchers working on that at the minute and simplifying them so that they can run still on relatively powerful microcontrollers, but it's still maybe a battery-powered device. And talking to Impulse, one of the things they were saying was that they're using a cascading approach as well. That's becoming popular. So you have 2 or more machine learning algorithms. The first one is used to make an initial decision. Is this, for example, if you had a doorbell camera at a house, the first decision would be to make, is this a human or an animal? And if it is a human, then I can then turn on the second large machine learning algorithm, which maybe is more energy intensive, and then use that to detect, is that somebody I know or I don't know? And so that cascading approach is almost like pre-filtering for battery-powered applications.
I also think more and more is possible with large language models. And yeah, you are not using them only as large language models. The results of these large language models is merged with some other results you get in a different way. For example, I was this morning at a company called Driver. They got this embedded award in the category software. And they are using large language models to make automatically a technical specification of, for example, code, but you can also enter data sheets as PDFs. And yeah, that is they are not only using the output of the large language model, they integrated in their tools suite also a compiler, which is actually compiling that code. So they get a really deep insight in that code. So they get an even better technical specification. I think that's a really nice application. And I think we will see more of these things in the future. So merging different models or merging AI with traditional tools and so on. I think there are many things to come.
Yeah. Now, I was listening to a podcast that was also talking about the integration of AI into different types of applications. So SAP, for example, is integrating AI. And I think one of the key things they were saying as well, AI is a support tool. It's going to help us. And really, for most applications, we won't even need to know that it's AI that's behind it. It'll just become something that sits in the background and does some clever things for us. So, yeah, interesting times ahead.
Yeah, and I've also noticed in the march towards AI, Raspberry Pi and Arduino, for example, are not using their traditional color schemes like the bright blue and the pinkish color. The Raspberry Pi kiosk is now dark gray, and Arduino's gone in that direction too, to appeal to more of the industrial customers. And Raspberry Pi has industrial partners there at their booth. So it's largely Raspberry Pi, but I think more than half of it is taken up by other companies that are using Raspberry Pi Compute Module 5, for example, to make PLCs, to use AI. I saw a very fast-moving object detection and person recognition and posture all at the same time while hundreds of people were milling about. It was picking them all up. So it is Skynet in a way. It's getting scarier. I mean, there was a time when if you had an infrared detector outside to protect your house, the dog would walk past and there's false alarm. Then you got to, you can tell a dog from a human. Now you can tell which human. And where's it going to go from there?
I mean, it's at the end of the day, it's a question of how the technology is implemented and for what purpose. But I think the incredible thing that we're seeing is just the fact that even low performance microcontrollers are capable of running machine learning algorithms, and I think this is sort of what gets lost in the mainstream media, that everyone gets upset and worked up about ChatGPT and Midjourney and all of these things. But what we see at a show like this at Embedded World is where there's tangible benefits to society, because machine learning can do things which are difficult to program in a switch statement and an if statement. There's very fine differences between some inputs, which would mean the difference between making one of two choices. Very difficult to write that as a software program, but as a simple neural network or as a machine learning model, much easier, much more efficient. And one of the applications that I wrote about was it's installed on the electrical grid on the pylons, and they use it to monitor the electricity obviously passing over, and the insulation helps to avoid, say, fire starting from sparking and other problems that can occur on the electrical grid. And that's all networked obviously with a wireless network, and as that machine learning algorithm's running, it's doing the same on lots of other nodes. All the data comes back to the mothership, it gets analyzed, and where they see an opportunity to improve it, the improved model is then distributed back out to the existing hardware that's installed. So yeah, exciting times.
Yeah, and one of the ones I found interesting as well, and I know we've all had a look at it and we've covered some of it online, was that amazing smallest microcontroller in the world from Texas Instruments.
Yeah.
Looks like, as Stuart said, like a couple of flakes of dust.
So which microcontroller technology or core is that based on?
It's an ARM M0.
Yeah.
And they are talking about, I think, 20 cents if you order 1K.
Okay.
But there were guys in front of me, I think I can tell it, they were interested in millions or something like that. So they really had an application for it. So also for that size. It could be, for example, integrated in cables or something like that. It's interesting. Yeah. And it has a rich set of peripherals. I think 3 ADCs, SPI, and so on. So only 8 pins.
8 pins.
Really tiny.
Well, you can only fit a byte in there.
Now, one of the other interesting pieces of news was from Red Pataya. I don't know if you've dropped past them. So Red Pataya's well-known company with their instrumentation, multi-instrumentation tool. They call it the Swiss Army knife for instrumentation. So it's a credit card sized board, similar to the Raspberry Pi in some ways, but it's got 2 analog outputs and 2 analog inputs, RF capable. Behind those, there's an FPGA. And it can be through a web browser. You can actually then use it for all sorts of types of instrumentation applications, also software-defined radio. And talking to them, they've just launched their Gen 2 board this week at Embedded World. I need to remember which exhibition we're attending this week. And it's a very good. I know, yeah. So just to go through the benefits there for those who are looking to do something new. And I've got it in my notes here. Yeah, so up until now, they've had sort of three keyboards. There's the STEM Lab, which is more focused on education. They've had the one that was focused on software-defined radio. The third board was so basically their development board, which industrial users have been using, researchers, science labs, things like that, for all these complicated experiments in quantum computing and also laser measurements and things like that. But the new Gen 2 product, the whole front end has been redesigned. It's a lot lower noise, a better signal, a lower level of signal distortion, better improvements around crosstalk. And one of the things they've also done, which I think is a great improvement, they always had a micro USB connector on there for the power. So they've at last updated it to USB-C. And the nice thing about that is that brings some additional advantages as well. So that can also be used as a serial interface. It can be used as a host interface. And they also get rid of the old SATA type connector, which they had for daisy chaining boards. So it was possible to link lots of boards together with a common clock. That's all done now via USB-C as well. So that makes it easier. And then, yeah, just more power and performance with the Z7020 based FPGA. And more memory is available. And another interesting point as well, in some of those research science applications, in order to do the experiments, they commonly have a clock set up, a very high performance clock in the in the laboratory. And with the previous generations of boards, it was a bit difficult to use an external clock source and synchronize that then with other pieces of equipment. So they've changed. They've added a third connector, and that supports the clock. You can also add a hardware watchdog, so you can have remote applications, and if they fail for any reason, it gets restarted for remote applications. And there's even more digital pins on there as well. So, and they're direct to the FPGA. So you've got like 1 gigabit performance pins on there as well. So yeah, some more interesting products and something that the industry has been asking for in terms of improvements.
Yeah, for sure. And I am looking at the comments here. If I seem to be rude, I'm taking care of the viewers. Baltic Lab says hi. Good afternoon, everyone. Baltic Lab, why aren't you actually here? You should have come and visit our booth here at Nuremberg. Another regular, Pratt H says hi. Hi to you. And May Queen Technologies says good. Now, I want to bring up that picture you took, Jens. That is the Texas Instruments board we were talking about. I mean, that is so tiny that
that is the one. That is the one on the very right, near the battery. That is the microcontroller. You can hardly see it.
1080p, because that's probably smaller than a pixel. What else can we discuss, Jens? Because you've given us quite a few photos. If you want to stop on anything here.
So this,
yeah, that is a nice demo I've seen at the ST booth. That is actually a robot. I don't know the English word for that.
I say as well. Yeah, exactly, a kicker. Yeah. That's, I mean, this again, another impressive demonstration showing the performance of embedded systems. You know, and this is what it's all about: control of linear motors. Here's a couple of people looking for that microcontroller.
That is that is a micro LED display which is transparent, and that company Tianma, they also won an embedded award. And yeah, the next picture is showing the proud winners of the embedded award in the category software. We have spoken about that. That is that driver tool, but they are not talking publicly about prices for the license. You have to come in contact with them. It is based on, they said, a user license and consumption. So it depends on the task you give to that tool.
Okay. Yeah, I think, you know, this,
it's a very interesting approach. I think that is the future of documenting and commenting code and so on.
Yeah. And also that sort of, I think this, the way of working as well. I was talking to another company that I work with regularly, and they're saying lots of companies are not allowed to install software, or there's very strict rules regarding installing software. And many of them, to get around that, they're preferring to use online tools. And therefore, you know, we're coming into that, monthly payment schemes to access tools and the scalable pricing. So I think that's a change we're going to see in the industry as well. Just trying to find one of the other areas. Another key area that's coming up a lot is in the area of security. So if the Cyber Resilience Act coming into force in Europe, and essentially what that's going to do is it's going to be integrated as part of the CE marking, if I understood correctly. So in future, if you want to sell any products in Europe, you always have to have a CE mark. And in future, if it's an IoT type application or includes any secrets or passwords and things along those lines and is electronic, it will also need to have passed security testing. Now, this is a really big issue. I think in the industry, we've often relied on obscurity as a form of security. The fact that you need a debugger to program a microcontroller, you need specialized tools, they're hidden away somewhere in the vehicle. Unfortunately, that just doesn't hold water anymore. I've heard stories about, for example, fuel tankers in the sea where they basically charge people to refuel. And there's an SD card in the system which is supposed to keep track of how many liters or thousands of liters have been transferred.
I see.
Someone takes out the SD card and just reprograms it and save some money on their fuel bill. Or even an SD card in a security camera, for example. people are still the camera to get the SD card and find out what the Wi-Fi code is in order that they can then access a network. And they don't care about the camera. What they care about is the access to all the data that network provides to them. So there's all sorts of nefarious reasons. And other areas as well. For example, we were talking to Windows Snyder from Thistle Technologies. That's a new startup which is focused on helping to improve security in embedded systems. Windows Snyder herself, she's worked previously at Intel, Apple, and she was part of Mozilla in the past as well, and has been the chief security officer at those companies. Those big software companies have obviously got their security side under control. Is a really important part of Windows and using a web browser and all those web technologies. But then you look at the embedded world, and obviously they look at it and just in shock horror that not enough's being done. So they're looking at helping people to do secure boots. So I know what firmware I'm loading from the moment the power's turned on, and also to do a secure over-the-air update. So I'm only receiving firmware updates which are signed and approved for my particular application. So yeah, so those are the sort of things that we've been seeing. What else has been good? Oh, so automotive remains one of those really exciting areas as well.
Of course.
Yeah. So I'm not sure if how much we've spoken about it in the past on the Elektor magazine and on the website, but essentially there's the automotive industry is in a lot of trouble. Basically cars are about mechanical engineers turning metal into transport. And then times have changed. Now it's about turning software into
software-defined vehicles.
Yeah, exactly. So, and in order to do that, we need completely new architectures and completely new microcontrollers. So, in a typical vehicle, you've got anywhere between maybe 50 to up to 100 or more ECUs, the electronic control units. That's how cars have been implemented for years now. And every time you wanted to add an additional feature, you made another ECU dedicated to that particular function. You hang it on the CAN bus. You might have a central gateway to allow that to be programmed or monitoring, and when you go to a service station, that they can analyze everything. But it's all sort of distributed computing. And what we're moving to now is a more centralized computing platform. It's called a domain architecture. So the idea is to have some sort of high performance computer at the center of the car that's connected to maybe 4 domain controllers in the corners of the car, and each domain is then responsible for talking then to maybe some smaller but tiny by comparison to today, tiny little sensors and actuator controllers spread around the vehicle. We're talking about saving kilometers of cabling through this process.
Yeah.
But we also need really high performance processors that can not only deal with all the data that's moving backwards and forwards, making all the decisions in these often safety critical applications. The other really key important part is that we need to be able to have mixed criticality on these things. So what we're talking about is having even hypervisors running on these systems. One hypervisor might be an ASIL-D, so the highest level of safety criticality, right next to something that is not safety critical at all, like the air conditioning system or some sort of user input or something like that. So now, NXP has been big on that. We've talked to them in the past before. They have their S32K family. They've just introduced the S32K5. So inside there's the Cortex-R family. It's an R52, and that's ARM's real-time processor, high performance, so many hundreds of megahertz. They've also got an M7. That's mostly for handling sort of real-time communication, CAN communication, Ethernet, and all those sort of things. And then a low power one as well, because when the car's turned off, especially with an electric vehicle, the electronics has to remain awake in the background, doing some sort of background tasks, but at a very low power consumption. So that's what the Cortex-4 is used for. And one of the interesting things about that particular product is they're moving away from flash memory. So they've removed the flash memory because flash isn't particularly scalable in a semiconductor technology. It takes up a lot of space. And they're moving towards magnetic RAM. So you've got MRAM. Advantage of that, it can be programmed without any high voltages like you need for flash. And it's also much faster to write. And you don't have to do page erases like you do with flash memory. So typically, if you want to make one bit change in a flash memory, you have to copy the page, erase the page, make the change, and write it back. With MRAM, it's a bit like, it's a programmable static RAM almost. So, and that also aligns very well with the software-defined vehicle process because it's much, much faster to program, about 8 times faster than a flash. Yeah, so.
We'll take a look back at your comments there, back at home. Jens, you said you didn't know what that game was in English. I think it's also called football in America as well, but the other option is table football.
Thank you very much, Michael.
And Multiclab says the reason he's not here, he just learned today that the embedded world is currently in session. You are not keeping an eye on the Elektor as much. We've been talking.
That's right. You should read our newsletter.
Malcolm Swart says hello from South Africa. And we've got a couple of holas and good days to you. But for now, let me take a note to talk about our sister publication, our cousins, and they are here at the moment. EE News Europe. You know about EE News Europe. We've spoken to them. We've spoken about them on the show before, and they are covering the latest in electronics and engineering news. So check out eenewseurope.com, which is an Elektor international media publication. And it's a fully digital publication covering the global electronics market with specializations in analog, automotive, embedded, power, smart 2.0, and wireless technologies. So read eenewseurope.com and subscribe to its newsletters, just as hopefully you subscribe to ours, to stay informed about essential industry news, key events, and technological innovations. So that's eenewseurope.com.
Super. Now, one of the interesting parts of being an embedded software developer is at some point adding a display to your product. I think we've all sat down with a microcontroller at some time and added a few LEDs and a few push buttons. And then sometimes you get that itch and go and urge and think, oh, wouldn't it be great to have a little graphical display on this as well? So you have a nice black and white alphanumeric display. It's also not enough. Sometimes you want a color TFT or something like that. Now, the big challenge is when you start to do the maths is if I've got a few hundred pixels to drive, how am I firstly going to control them all? And secondly, where am I going to find all the memory to store the graphics? So I think one of the big challenges I saw in the industry as well, when I was working at Microchip, for example, we introduced a new microcontroller with a graphics interface on it. But one of the challenges with selling something like that is you go to a company and say, oh, you want to add graphics? Yes, we can support you. But if they're not already using your technology, they got to move microcontroller. They need to learn a new tool chain, new development environment, new debug tools. It's quite a lot of effort. So we went over to talk to Bridge Tech today. Gavin Moore over there is a guy we've spoke to in the past before. They're actually related to FTDI, who do the USB to UART converters. So they have a great load of technology and understanding there. What people might not know is through their sister company, Bridge Tech, they have, which is an embedded video technology. And they've just brought out the 5th generation chip. And the idea is that essentially, if you've got a microcontroller with an application that's working and you want to add graphics to it, add a touch screen and all those fancy things which make embedded systems so easy to use, you can actually attach their SPI-based EVE chip on the side and let that do all the graphics for you. So as an LVDS output, that allows you to attach a color display up to 15 inches. It also has an LVDS input as well, so you can take a video input from a camera. And that chip has got loads of like abilities to mix the video, modify the video images as well in real time. It's also got an I2S output for audio, an I2C interface for a touch screen. And then you can sort of instead of trying to build graphics into your existing application, you can just add their chip and stick with a technology and a tool chain that you already know.
I should ask for an eval board again, because years before I asked and I never got one.
Well, I'm sure that's it. I mean, this is the interesting thing. So the latest chip that they just brought out, the BT820, they were saying that I think it's the first BGA chip that they've ever produced as well. And they were concerned that their traditional customers would go, oh, not really sure what to do with a BGA device. So what they've done is they've created a credit card size development board. With that, you can start to develop your application. And then if you want to, they do a little mini module. So very similar to the CM compute modules from Raspberry Pi. That mini module can then just be taken as it is. It's got the BGA chip on it. It's also got DDR3 SRAM on it as well, DDR3 RAM. Yeah, so you can just take that module and integrate it into your system, so you don't need to worry about all the complexity of soldering.
But I think they are heading towards automotive and these customers.
Yeah, so there's a mixture there. So definitely the fourth generation product is now qualified for automotive temperature ranges. And that also makes it suitable for some other applications where there's greater demands on the device, like medical as well. But otherwise, they're a very wide range of also complete modules. So those chips are also built into modules with displays and touchscreens. And they're used in all sorts of things like thermostats, as a rotary interface with a round screen for a thermostat type application. They've also got examples for hot working desks, for example, where you can actually reserve the space. There's a display for that with a little QR code, or even a room reservation system. So part of those building management systems applications where you need something visual, a room, or even branded.
Okay.
Yeah, so yeah, a real mixture of stuff. So that was cool.
And now that we're back, I saw that it was certainly very busy as we started out, as Malcolm Swart in South Africa says, asking how the attendance is on the first day at Embedded World. First day was busy, but today has felt even busier to me. I don't know how you guys feel.
Yeah, so I think one of the things that was highlighted very early on, just on Thursday, Friday last week, just before everyone started to try and travel, was that there were strikes here in Germany at the airports, which caused a lot of people to have to reroute. Even Roberto from our team, he was telling me that he was flying from Milan to Nuremberg. He ended up flying from Milan to Rome to Munich, and then drove from Munich. I've had other sort of old colleagues of mine, they took the train over, or they drove over from the UK rather than flying. So it's been pretty crazy. But despite that, that doesn't seem to have affected attendance. I mean, typically when you talk to people, they've all sort of said different things about how busy it's been. So some people have said it's been busier in the afternoon. Some people have said there's like an hour where it was a bit quieter. And that to me indicates that that's just a normal embedded world. And as you said, Brian, today has been really packed, and people I've spoken to today as well saying that I
also think so. Today is really crowded. So at some booths, it was so crowded that you could not reach to the demos.
Yeah. We have to say that the typical cycle of Embedded World is Tuesday's a little bit quieter. Wednesdays, everybody's here.
Yeah.
And then Thursday's student day, and it gets a little bit quieter. But I think we'll see the numbers. They always produce the numbers afterwards and tell us what the attendance was. So we'll find out from there.
Yeah, and that's actually a good point about the strikes. I dodged a bullet. I wasn't affected by the strikes directly because I came in on Sunday. However, they were going slow anyway. Yeah. Border Patrol and security. I missed my connecting flight, but fortunately, Lufthansa just booked me on the next one for free. I didn't know what to do. I asked ChatGPT, and it guided me through the process of getting.
Glad it didn't hallucinate.
Yeah, hallucinate. Send me to Swiss Air or something. And then I just wanted to point this out. We've got this book on how to get started with the NXP Freedom Board, and obviously we've got the boards, and they come as bundles and so on. But this is just a prop, so I can show you my next photo. NXP is going big on Freedom boards. I mean, the entire thing is packed with Freedom boards. Or FRDM, as we called them in the beginning, but Freedom boards. They're certainly making inroads into that particular market that they're after. Have you worked much with the Freedom boards or covered them much?
I haven't worked with those boards, but I have spoken to NXP in the past. I mean, I think this is also, I mean, the point is Arduino sort of kicked off this trend of making microcontrollers easier to use, easier to program. And the semiconductor industry, the microcontroller vendors have sort of jumped on board with that format over time. and are looking to, rather than have these very large boards, which weren't very particularly pretty, and a new board design for every new product that comes out, it has sort of pushed everybody in the direction of making a standardized format and standardized pinning, which has been really good. One of the other important things is you see the click layout as well for the micro E module. So that makes it a lot easier for people to modularize a prototype and try out new sensors, new interfaces, new displays, and things like that. So yeah, other than that, I think it's, there's everybody out there seems to be looking to provide an easier way to get into the world of microcontrollers and give people a sort of hand up exploring alternatives to whatever it is they're currently using. So I think it can only be good for the industry that there's that engagement and trying to make things simpler.
Yeah, and speaking of making it easier to get into embedded, we three are embedded at Embedded, bringing you the best reporting from Elektor. So let's talk about our giveaway for this show. It is our book called Embedded in Embedded, and there you see it on screen. And lucky viewers who get randomly selected, who get the code word correct on our giveaway page, Elektor Lab Talk giveaway. The code word we've chosen for this one is EW25. So visit elektormagazine.com/elektor-lab-talk-giveaway, and the code word is EW25. So enter that code word, and good luck with that.
And while everyone's jumping to the website and adding in that code word, EW25, to win that fantastic Embedded in Embedded book, it's a good opportunity to highlight another little interview that I did yesterday, which I thought was quite interesting and aligns very well with the discussion about user interfaces and graphics. So I think all of us have had a bad experience with a user interface, probably on a printer or a fax machine, trying to work our way through the menu options. Now, I met a company called KDAB. They're actually a consultant in the area of user interfaces and graphical user interfaces, user experiences, UXs, as they're also called. And that was a really interesting discussion. So their focus is on an environment called Qt or Qt. That's an offshoot of Nokia for doing visual interfaces. They also support a Rust-based user interface environment called Slint. Yeah. But what was really interesting was to sort of understand how they help their customers with their user interface design. And they were saying, like, lots of people come along with a sketch, typically 3 or 4 squares inside a square, looks very much like an iPhone. And often these things, from their perspective as experts in user interfaces, it often throws up more questions than it answers. And one of the examples they gave was as a company that does tipper trucks. And one of the problems that they were having is because the users of the tipper trucks were all from different countries, spoke different languages, they didn't necessarily understand what the interface meant and all this sort of stuff as well. So while trying to tip a load from the tipper truck, sometimes for safety reasons, the whole things would come to a standstill, and they didn't understand why. They thought the system was broken, and there wasn't proper feedback. And the company decided, we'll do a mobile phone app. That's about as far as they seem to have thought it through. And one of the interesting things KDAB was saying to us was what they can do, and as part of their team, they obviously have software developers and project managers. That's a big part of it. Graphic designers, but they actually have a full-time psychologist as part of their team, which I found fascinating. So when they get customers who know they need something but aren't quite sure what it is, they send the psychologist out and they start to do that in-depth research into the human interface, the person-to-machine interaction, and really get a better feel. And in that particular application on the tipper truck, they went from having something that didn't quite make sense, looked a bit clunky, to actually receiving a design award for the resultant application that was developed. So it's just interesting to see that although we're very much in engineering, software development, microcontrollers and compilers and safety systems and all that sort of stuff, there's that creative hand and also that psychological aspect that's a key part to make those things work.
Yeah, and you'll have to excuse me for being so busy here at the studio back home. I've got multiple screens where I can keep an eye on the chat, but I'm queuing up photos here. I'm looking at the chat, all on this little screen I've got in front of me. But here's a good comment from Julio.
So Julio, you have issues with your user interface for your projects. Well, it's probably a good opportunity to share them with us, and we'll see if we can connect you up with an expert.
Yeah, or maybe just get a psychologist to help you. We've got a few minutes left. This place closes in 14 minutes and they're going to kick us out then, especially our team who've been on their feet all day. But we can have a discussion about a few more of your photos, Jens. Tell us what's happening there.
Yeah, that's actually an XP, as you can see at the color of the sky. And yeah, he's showing the latest demo about Matter. There's a new specification called Matter 1.4. And this guy told me it's integrating, I think it's called at Matter Profile, I'm not sure, but a new category of or type of values. It's for energy consumption and energy generation, which is, I think, a very good idea, because then you can also use Matter, for example, to transmit the energy of your, not the energy, but the number, the size of the energy your solar modules generated, or the consumption of your house and so on. And NXP is actually showing a demo that, for example, Matter gets the weather forecast. So it's snowing, and so you know from the solar modules there won't be so many amperes, so many watts anymore, and you have to turn up the heating. So yeah, that is really smart, I would say. That is, I think that is, not sure, that is, I think, Code Fusion from Analog Devices. Yeah, that is from RAG Wireless. They have made two new LoRa modules integrating not only an STM32 for basic functions, also an ESP32. So they have actually two controllers in these modules, and the STM32 is for low power, and it wakes up the ESP32 to do communication when the communication is scheduled. So yeah, that's also a nice nice module. I've seen more and more modules where more things are integrated. I think that's also a trend, more integration. Not only communication, also central processing unit inside a module.
Yeah.
You see that more and more because you have, of course, cost savings.
Yeah. I think that's one of the things, a trend that we're going to see. I was talking to Analog Devices recently, and they've got a complete division which is dedicated to building modules. I mean, and you can sort of question why on earth is that necessary? You go to the Analog website. There's so many really good quality application notes. There's some great development boards. If you want to make some complicated analog front end, there's enough information to do it. But I think part of the problem is people are having trouble finding analog engineers capable of designing those things. Once you've designed it, there's a lot of work that goes into refining the printed circuit board in order to get the noise levels you want, the performance you want. And lots of people, they know what they need in terms of a performance system to measure something, but they don't necessarily want to build that system themselves. They want to have the analog front end ready for them. And they're also going very much down that modular route to have everything on a board to be able to tackle a particular type of application. Just saying this as well as the Edge AI booth. Just down in the bottom there, you can see the little car parking space with all the cars in it.
We don't see it in the pic.
There we go. There it is. Yeah, and this is a Qualcomm based application. If I recall correctly, Qualcomm 9070 was the chip. I mean, it's a very high performance chip. It's almost like a miniature PC. But this thing is running this very large language model. There's just like you would with ChatGPT, you've got a series of prompts. You can see that on the screen there on the left hand side. Basically, when the application is run, it goes through the large language. It's a standard large language model, so it can recognize all sorts of things. But you ask specifically, can you see a car or some sort of vehicle? Yes. can you classify that vehicle as either a car, a truck, or a van? After it says, can you classify the manufacturer of that vehicle? And then it asks about whether the type of vehicle is a passenger vehicle, a truck, some other kind of application. Now, all of that is running on a server on the Qualcomm part. Yeah, it's just incredible to see that sort of ChatGPT type technology just running there on a tiny little board. Had a hefty fan and heatsink on the back as well, though, so not really portable or for your pocket unless you like warm trousers.
Oh, yeah, absolutely. And I'm not a fan of warm trousers, to be honest. I think with that we'll have to wrap it up. That's been a great update. Thanks to you guys for wearing your feet out as much as we all did and bringing in the latest news. Thank you to Stuart Cording for joining us this time on Lab Talk.
It's lovely to be back again. Really enjoyed it.
Great. And Jens, once again, chefredacteur, thanks for being on the show.
Always a pleasure.
And thanks to all of you for joining us. And good luck if you're entering our giveaway for Embedded in Embedded and from all around the world. Thank you. And good night, good afternoon, good morning, wherever you are.